So today the topic of our discussion is how to construct pigeonhole diagram and how to derive term symbols by using pigeonhole diagram. As you know that we have two type of term symbols, like the ground one and the excited one. Okay, the term symbols of excited can be determined using pigeonhole diagram. This one, where the vertical axis represent the small ml value and the horizontal axis represent the capital ml value. Okay, now there are some rules to construct pigeonhole diagram. Okay, so while constructing pigeonhole diagram you must have to adopt or to utilize some rules. Okay, the first one is each horizontal box is represented by a capital ML, means this horizontal box, when moving electron in this direction, you can place 1 ml value in each box. Okay, the first electron must be placed with spin up, not a spin down. Okay, and again the first electron must be placed in the higher ml value. Okay, I would like to add this additional point over here, and the second electron must be in the column above the first one, okay, so as to avoid a duplication like this. Okay, now the third one is in the column systematic arrange the electron in the higher ml value, first in this +1, second in this 0 ml value. Avoid by placing like electron in the higher and then in the first in the higher ml value. This one is wrong. Okay, so this one is a wrong placement. Again, this one is, you can say, not following the Pauli exclusion principle, which says that no two electron can have the same set of quantum numbers. Okay, here this one is okay, but this one is not okay. It is against the Pauli exclusion principle. So in a nutshell, we can say that while constructing pigeonhole diagram, we must follow these rules. Now we have two types of, as we have mentioned, that we have two types of term symbols. The one that originated from the ground state is called ground state term symbol, mean. Here the electrons are present in the ground state. Like in hydrogen, if the electrons are present in one s1, the term symbol in this case will be duplet half. Duplet is a half. If this one electron is promoted to 3D, the term symbol will be changed. Now this one will be called is an excited state. We know that the azimuthal quantum number represent the subshell notation. If L is equal to 0, the subshell will be S. If it is 1, it will be P, and so on. And the capital L represent the spectroscopic term. When it is equal to 0, the term will be S, the capital S. Well, the subshell is represented by a small alphabet, whereas the spectroscopic terms are represented by a capital alphabet, that is capital L. And we know that in case of carbon having 6 electrons, the electronic configuration will be 1 is 2, 2 is 2, 2p, 2. So here we have 2 electrons, and we have to arrange these 2 electrons by using a pigeonhole diagram and the 3 degenerate orbitals. Okay, as we know that for p sub shell we use notation L, and L here L is equal to 1. Okay, so if it is 1, it means it is p sub shell. Here the 3 ml, what actually it represent? It tells us that when this p sub shell or L is placed on a magnetic field, it is oriented into 3 different directions: +1, 0, and -1. So this ML will represent the orientation of the orbital of subshell P under magnetic field and various orientations. So the 2 electron can be added in 3 degenerate orbitals in a different way. Okay. Now how we place these electrons? Actually, by using pigeonhole diagram, you can place these electrons by first placing this 2 electron in the higher ml value. But before going to place this electron and just to move this electron, let's first talk about the L1, the ml, the capital ML, the MS, the spin multiplicity. We know that for P, L is equal to 1. So the ml value will be +1, 0, -1. Okay, means ml will be ml1 plus ml2. Here ml means orbital angular momentum, while the spin multiplicity is by a capital M and S, that is equal to ms1 for first electron, ms2 for the second electron. It is called this S is called spin angular momentum, while spin multiplicity is represented by 2s plus 1. If this is 1, we call it singlet. If this is 2, 3, we call it triplet, and so on. Now coming toward the placement or the arrangement of electrons by using pigeonhole diagram. Okay, actually first place the electron in the most higher ml value. Now just move this electron in this direction and this one in horizontally. Again we have another combination, so we cannot move this electron further. Another representation is when both the electrons are in downward direction. Just move this one in this direction, and this electron in this direction. Keep on moving these electrons. Okay, here the spin multiplicity is triplet. Why? Because S is 1 over here. 1 by 1, 1 by 2, plus 1 by 2, it will be 1. By putting this one in the 2s plus 1 formula, we will get a triplet. Okay, this one. Got it? Now just erase it. Here, in this case, it is singlet. Why? Because both are paired. So S will be equal to 1 by 2 minus 1 by 2. It will give us 0. By putting this 0 in this 2s plus 1 formula, we will get a singlet. Now coming toward the number of sets or the type of term symbols, how many term symbols are possible from this pigeonhole diagram? We will discuss it in the next slide. It is a complete pigeonhole diagram. However, we will work only with a partial pigeonhole diagram because it can fulfill our requirements. Here, how to like add these ml values? First, we know the first electron is in plus 1, so plus 1 into 1 mean 1 electron. Okay, the second electron is in 0, plus 0 into 1, that will give us 1. That's why we have a written a 1 over here. Okay, again for S, for this particular one, the first one is ms1 1 by 2, the second one is also 1 by 2, that is ms2, that will give us a 1. Okay, on the J value, this is called the resultant angular momentum is equal to L plus S and L minus S, the maximum and the minimum. Now coming towards the partial pigeonhole diagram, the movement of electron will be in the similar fashion as we have discussed in the previous slide. This electron will be moved over here, this one horizontally. Another arrangement, we have not any other box or place to shift these electrons. This one is another arrangement, just push this electron in vertically and this one just move it horizontally, this one vertically and this one horizontally. Okay, another set, just move this electron vertically and this one horizontally. Okay, now we have three type of sets. Set 1, this one, here the ml value is 1, means it will be plus 1 0 minus 1, like plus 1 0 minus 1. So we know that if L is equal to 1, the spectroscopic term, here the spectroscopic term will be P. This spectroscopic term will be P. Okay, now as we know that S is equal to 1, so the spin multiplicity will be triplet. That is why we have written triplet over here. So the term, or you can see the half term symbol will be triplet of P. For the whole term symbol you need J value as well. So J is equal to L plus S up to L minus S. Just put the value of L and S. We will get 2 1 0. So the term symbol will be triplet P2 1 0, or we can separate it like 3p2 3p1 3p0. Set 2. Okay, here the set 2 is where the ml value is 2 and the maximum ml value is 2. So it will have plus 2, plus 1, 0, minus 1 and minus 2. And we know that when L is equal to 2, the spectroscopic term will be D. Spectroscopic term will be D. And we also know that when S is equal to 0, the spin multiplicity will be singlet, as we have discussed it in our previous lecture. So the term will be of the half term symbol will be singlet D, and as S equal to 0, L equal to 2, so J will be 2 plus 0, 2 minus 0 will be 2. The term symbol will be singlet D2. And the third one is 0, where the ml value is 0, so we will have the term or a spectroscopic term will be S, as the 0 lies in the singlet state here. So the half term symbol will be singlet S. For complete term symbol we need J. So J is equal to L plus S up to L minus S. Here the term will be 1S 0. Now coming to the total term symbol, we have singlet D2, triplet P2, triplet P1, triplet P0. Actually, what is term symbol? Actually, it is the abbreviated form of energy, level, total angular momentum, and spin multiplicity. How? Total term symbol is equal to 2S plus 1 in the left corner. Just put this spin multiplicity, the left corner. Here is the J value. So according to Hund's rule, the ground state term symbol will be that one that arises from the higher ml value electrons. Okay, here is the know that the ground state term symbol is a 3p0 because electrons are less than a half filled. So according to Hund's rules, if we have term symbol with same spin multiplicity like 3p2, 3p1, 3p0, we'll pick the term symbol is the ground state having lower value of J, higher L value and higher spin multiplicity. The rest are the excited states. Now the total degeneracy actually tell us about the ways, the possible ways, the total number of ways of excitation of these electrons, or you can see the arrangement of these electrons. So here we have 15 possible ways of arranging these electrons. Well, here if L is equal to 1 means P term or P sub shell is equal to 1 triplet, putting this L value over here, spin multiplicity or S value over here, we will get a 9 energy levels. For L is equal to 2, is equal to 0, singlet, just put the value of L and S, you will get 5, and the same is for S. So here we have 15 possible ways of arranging these electrons. Here these terms singlet mean that we have paired electron, or we have a electron with parallel spin, 1 plus 1, 1 plus 1, that will give us 1. By putting 1 into S will be 1. Here again doublet mean S is equal to 1 by 2. We have only a single electron, or triplet. Here it is a singlet, it is paired 0. Okay, for triplet we have paired electron mean S is equal to 1, and for quartet we have 3 electron in parallel fashion where S is equal to 3 by 2. Well, here's a slight reminder for the quantum numbers. We represent the principal quantum number by n, is a mutual quantum number or orbital angular momentum quantum number by L, magnetic orbital angular momentum quantum number by ml, spin by S, and the magnetic spin quantum number by ms. Usually 4 and 5 are used interchangeably. While in derivation of term symbol, we will have to add the L value of the electron. If you have 2 electrons, just add L1 of first electron to L2 of the second electron. Mean it will be like this manner. L is equal to L1 of first electron plus L2 of the second electron. and so on. Okay, the L value actually ranges from maximum to minimum. One thing we must keep in mind that while adding the L values of electron, take the L1 value the highest one for those subshells if the subshells are different. Like P1 D1 we have, for P we have L is equal to 1 and for D we have L is equal to 2. Now if you take this L1, P is equal to L1 is equal to 1 and this is equal to L2 is equal to 2, we will get a negative value for the L. Okay, in the same way as we have added, or we can add, or we all should try to add L is equal to L1 plus L2. In a similar fashion, we can add the S values of electron. Here again, just put like L1 plus L2 like 2 plus 1 up to 2 minus 1 will give only 1. But if you put it like 1 minus 2, 1 plus 2 up to 1 minus 2, you will get a negative value for L. So to avoid this negative value, we must take L1 is equal to 2 and L2 is equal to 1. Thank you. Please subscribe, share and like this lecture as well as this channel for more useful videos. Allah Hafiz.